It's time for episode 2 of the ZX Spectrum definitely not copyright infringing ENDURO-REPAIR series. Adrian pointed out that Jan Beta might have come up with the repairathon idea, so credit where it's due. When I left you last time, it was with a bitter taste of me selling you a lie.
I'm not sorry.
Well, it wasn't really a lie. I did say in the title it wasn't a repair, but I felt bad. I didn't actually fix anything. Well, today is a whole new bag of spanners. Power, but colours on the post-it. Place your bets now. Do you think lower RAM, TR4, upper RAM, ROM, ULA, cosmic rays? Could be anything. I like to guess the revision of the motherboard by looking inside the expansion slot. There are clues that will give you a clue as to which one it could be. The first thing to notice is the heatsink position. On issue 2 and lower, the heatsink is at the front of the case, so this one is a 3 or later. The colour of the motherboard's top surface can give a clue too. Darker greens are usually revision 4s.
Colour of the motherboard, 4S.
Terrible guess.
No, 2, oh no, 3, just a 3. And little tags of keyboard membrane left in there. So we've got another one with a broken membrane.
My initial thoughts.
It's like original caps, although these ones are slightly different colour to these ones. But maybe those have been replaced. Nothing socketed, no logic, nothing. We are 83, 83, 83. I'm going to say that's 82. 83, 8250, middle of 83.
Okay, let's go with 83.
Nice clean board. And look at God, that is a mess.
Yes, this speaker is looking dodgy. I'll have to remember to test that later. Initial checks time. Resistance first. I'm mostly looking for dead shorts here. Anything that would stop me from putting power into this right away. Nothing untoward on the voltage regulator or memory. On the other side, the coil.
Oh, might be a...
I'm getting some unusual readings here. And it turns out it's my multimeter.
Oh.
I really need to get a decent one of these.
Blame the tools.
You're the tool.
This is better.
A new set of batteries and it's working much better.
That's better. That's much better.
The coil will show some resistance with the probes one way round and none the other way. This is perfectly normal and has something to do with the way a coil works, which if you ask me might as well be magic. The joules per coulomb initial checks video goes into more detail if you're interested. I will put a link in the description again. Normally at this point I test the two transistors at TR4 and TR5, which are at the centre of the voltage conversion circuit. But for some reason I forgot and went right to voltages. 5 volt is coming out of the regulator.
Yep, 5 volts coming out of there, no problem.
The input voltage is lower than what the bench supply is feeding it, so there's a problem here somewhere.
Not quite 9 going in. Something's drawing it though. It's only 500 milliamps.
The top left pin is -5 and that's not reading correctly. Bottom left is supposed to be 12 volts and that is only 7.
5 volts.
The 5 volts is good. So it's something to do with TR4 and TR5 as that's where the 12 and -5 volts come from. If I had remembered to check these, I might have spotted this.
TR4.
It's not a perfect test while they're still in circuit, but if they've failed, you can usually tell. A test outside the circuit reveals...
Oh. That ain't right. Yeah, something going on there. The middle one's free. That one's free. Means I can just pull it out with this one. a 640 1K resistor and a 1.5 ohm resistor. That might be broken.
I tend to agree.
Cold! Hell, that's cold. That says ZTX 650.
I found a replacement and soldered it in place. Off camera, I also tested the voltages, which were now all present and correct. Before testing, I'll perform a super fast composite mod so I can see the pretty colours.
And
Okay then, pretty colours. Mostly red.
right, so what we need now is Dandanator. Oh, hopefully it works with this one. Yeah, I've not seen that one before.
That's quite interesting. It could mean one of two things. Either every lower RAM chip has failed, not something you see every day, or something else has failed so badly it's taken the whole system with it. I always test the ULA first. They're surprisingly resilient in the grand scheme of things, certainly when compared to the other chips in these computers. But they are always in sockets, so it's easy to stuff one into another board. What's the word, Lee?
And I can tell you that that is fine.
That's good. Hate it when these go bad.
ULA is good.
Again, off camera, with the ULA out of the board, I took the opportunity to probe around without that chip in its socket, just for curiosity. And, well, I'll let the clumsy bench monkey explain what he did wrong this time.
Okay, I took the ULA out to test it in another machine, and when I did, I accidentally poked the probe into the contacts, and I think I bent them. And I can show you why I think that. So if I turn this on now, we get nothing. Nothing at all. Turn it off. I press on here and turn it on. We still get nothing because I haven't turned on the power supply.
Idiot.
Alright, so not pressing it, turn it on, nothing. But I am getting some current draw. Right, now if I press it and turn it on, there we go. We get something. I'll let go, goes off.
So basically, you broke the socket. To be fair, these sockets are garbage anyway. I could probably bend that contact back into position and it would probably work. But it would be much more reliable to take it out and fit a new one.
Sorry, just let go. That one there. That one there. Just bent in.
Okay, new socket fitted. It's not likely to have been causing the initial problem, but I'll test it first in case I've managed to make something worse. Good, still the same kind of broken it was before. How about the Dandanator?
Interesting. Don't think the Dandanator's working, but I will give it a go. Like we've got a bit of socket in there. Might have a bit. That doesn't look very good.
Dirty edge connector. Nasty.
This one's for you, Dave. Loads of it.
Velociraptor Dave from the This Week in Retro podcast has a contact cleaner fetish. If this was recorded onto VHS, this is the bit that would be worn out.
Oh, I might need the fiberglass pencil on this.
If this was a dog-eared erotic novel, this is the page of the book that would open all by itself. Looks like the edge connector is in a bad state, so it's going to need a more aggressive pass over with the fiberglass pencil.
Already got some in my finger.
Right, that's made no difference. The Dandanator is still just displaying a total RAM error. I would prefer to have a better idea of which IC is causing the problem before I go any deeper. Maybe it's time to bust out the oscilloscope. It could do with being more than something that looks impressive on my wall.
Let's switch it on, and here is what I have found. So if I look through the pins on the ULA, everything is normal apart from D4, which is pin 27. So 1, 2, 3, 4, 5, 6, 7. That is D4. And if you look, these little, this doesn't look right. I'll show you another one. This is D5, which is 2 pins up. That's a normal data trace. That's what it should look like. But this isn't right. So I went off and looked at the schematics. Actually, no, first thing I did was scope the CPU lines. And again, everything looks good on there. But D4, 1, 2, 3, 4, 5, 6, 7. They don't look right. Now, that's just got the bad trace on. So I'm instantly thinking the CPU is bad. I'll show you D3, which is the next one down. That looks good. Okay. So it could be the CPU. Ouch, that regulator's getting hot. D4 on the schematic. There's a fourth one down there. It goes to there. There's a fourth one across there. It goes to IC 19. I don't know which pin it is. I'm sure we can find it. So IC 19 is probably that one. Yeah, it is. Pin 2. So if I show you the next one across, that looks good. Yeah, all the other data lines going into the upper RAM look good. So it could be that. And the fact that it's so pronounced on there and the CPU, they're quite closely connected. It also goes to the ROM on pin 16. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, it looks bad on there as well. So it could be the ROM. And it also goes, it is the fourth one up, fifth one across there, 1, 2, 3, 4, 5. It also, oh god, I've cut that bit off. Goes to one of the lower RAMs as well. I'm going to have to quickly look at that. So it also goes to IC10, which is this one, and that will be that data line. which doesn't look, that has that half thing like the ULA. I don't think the problem's there. I think it's either CPU, ROM or IC19. The most likely to fail, probably the memory. So, and it's the easiest to take out. Least likely to fail, ROM. The one I want to take out the most, the ROM. That's how I can put my diagnostic cartridge in. Let's take that one out.
Okay, that all makes sense to me, which is kind of what you might expect as it was me saying it. But basically, I'm basing my reasoning on the fact that where the trace looks worst is most likely where the failed chip will be. That's fair, I think. Do you agree? In this next half of the video, you will see me getting taken down a few pegs. For a long time now, I've been privately wondering to myself how other hobbyist retro repairers like me are managing to damage boards when removing chips. It's all been a bit too easy. It turns out I'm not as good as I arrogantly thought I was. In fact, I was just lucky to not get a problem board. Until now.
Oh, you might have taken a pad off there. Yep. Fact, I've taken one off there as well. Wow. I thought I was invincible.
Granted, this chip was a bit stubborn to remove, and I left the iron on a bit longer than I would normally. But there you go. Anyway, I'll try to be much more careful. No way I will lift another pad on this board.
Okay. 2 pads gone. That just goes to show you how delicate these are.
So, is this the faulty IC?
What do you reckon? It's not that.
Oh dear. So what next? ROM? CPU? Lower RAM?
It's very much not that. CPU or ROM. I'm going to go for the ROM. Simply because I can put the diagnostic ROM in there once it's socketed. I don't think it's the ROM. I think it's the CPU.
I'm banking on the diagnostic ROM giving me a clearer picture of what the problem is. So it's not the worst idea in the world.
I'm going to have to be extra careful now.
Yes, don't forget this is a super delicate board. You don't want to lift any more pads.
We've got a lot of room around the ROM, so I'm going to not worry too much about getting every bit of solder off from underneath. I'm not going to scrub.
Now I'm doing this with as little pressure on the board as possible. Also, for as short a dwell time as I dare. This does mean I won't get all the solder from the other side quite as easy. But there's lots of room around the ROM, so I can get the braid down the side of the legs on the top side and mop that up.
Loads of solder. Gotta be careful going down the edge of these with solder braid. This is really, really easy to rub the traces off. I've got a feeling this board might be a bit delicate.
Right, better be super careful then.
So I'm going to press them one at a time rather than scrubbing. Like so. Oh, look at that.
Something has happened to one of the pads. Oops.
Jeez, this board is delicate. Oh, they all look good. Gotta go for it. No movement. Nothing's moving at all.
This is a problem. I could reflow all the legs and try removing the solder again. And on a stable board, that might be the way to go. But that would probably lift more pads. So it's time to loosen it up with hot air.
Yep, lost a wire there.
And there you have it. Even being as careful as possible, I still managed to lift this off.
That was purely from heating up the top with the iron and braid. These are just falling off for fun. Don't think that's connected on this side anyway, so not a big deal. Didn't lose any on the other side.
And that's all there is to it. This is just a board that will fall apart if heated. So if you're struggling to work on a board and you think you're taking all the necessary precautions, it just might not be you. Not all of these were manufactured to a gold standard.
That is unfortunate. First things first. Does it still work like it did?
Good stuff. Making sure the baseline hasn't changed. I might be learning.
And the answer is your telly's off.
Idiot.
Yep, exactly the same.
Okay then, diagnostic ROM time.
What was our next?
More info. This is a great result. So, IC10 is a lower RAM chip, which, if I had approached this on a different day, would have been the first thing I suspected.
Cool.
It's always the RAM. Question is, can I get this out without further damage?
Alright. This one goes to 10. So I'm going to use hot air, solder sucker and then hot air.
I'm making sure all the legs are as straight as they can be. And going really gently with the desoldering gun.
It seems to go quite well.
And next, right to the hot air. Adrian Black uses this method almost every time he removes a chip. And I think I'll be doing the same from now on. But will it come out clean? No wires stuck to the legs? That's a good sign.
Oh, that's hot.
Bad chip!
Bad chip. Right, ready? Go. Looking a bit better.
Right, new sockets in IC10 and IC19, and fingers crossed this will be fixed. With the lower RAM installed, the diagnostics pass that part of the memory. I just need to install a socket for the upper RAM IC.
Okay.
But first I need to make sure there are no broken connections.
Okay.
The trick will be seeing if there's enough metal left there to solder the leg to.
This is the key. The wire's still there, it's just the pad's gone. That's fine. I bet that works.
Well, he seems happy with that.
Boom.
My apologies for the terrible picture quality of this screen capture. I upgraded that camera and am still getting to grips with how it's supposed to work. Yeah, that's not going to work like that. Blue tack doesn't have the right amount of bits.
Got to put the actual chip in, Lee.
So is it fixed?
Oh, RAM error.
Oh, bugger.
Let's try a different one. Damn these things.
To be honest, I grabbed the first one I could find and the legs are not great.
Oh, brand new.
In a new chip goes. And...
yeah, for a fault now. What?
well, it was testing okay before I replaced that upper RAM IC, so let's take that out.
I wonder if it's the data line. Lower RAM's okay, but not with that upper RAM in.
Could it be that both the lower and the upper RAM ICs that were attached to the same data line have been damaged?
That's quite interesting. Legs are very short on that. Let's get a new one. 4164. New. Brand new.
I need to restock, getting really low on RAM ICs with long legs.
What do you think of that?
And it's all good.
Good. Try the other one just in case. Yes.
All fixed? Yes? Wait, there's something missing. Replace the ROM and see if it boots to basic.
Yes. Look at
Yes, that works. But still, something else is missing. I wonder if the Dandanator works now.
No, no speaker.
Oh yes, no beepity beep beep beep. That speaker did look a bit dodgy. Off camera I removed it and tested the resistance, which is supposed to be 40 ohms. But this one was open circuit. I have a spare and popped it in there, but the sounds were still not beeping. There are a few other components to check if the speaker isn't working. A diode, a resistor, and this transistor at TR7.
Okay, so this is TR7 is attached to the speaker, and these two legs are shorted. And just a sanity check. It's a later issue board, but it's exactly the same part of the circuit. They are not shorted. Oh, I get to try my new component tester.
Oh, look, I have a new component tester. My mate, Simon Osborne, bought this for me.
It's a resistor.
We'll be hearing a bit more about Simon in an episode coming very soon, in which I repair his Amstrad 464 Plus. It's a doozy. The polarizing filter on my camera doesn't like this display. So that transistor is broken.
There you go. It's a resistor. I don't know if you can see. There you go. Right, ZTX 450. I need something that does the same job as that. Apparently a 2N3904 will do the same job. And it goes in the right way as well. So that's handy. Close enough.
Now, is it working?
Beep, 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 beep. Cushy. Spoil it. Right, yo. So, in summary, that chip was alright, the ROM was alright, that chip was bad, that socket was bad, that transistor was bad, and that speaker was broken.
That's actually quite a lot.
Cool.
And finally, the keyboard membrane. I need to remove the remains in the connector, but it's refusing to come out. Tweezers are too blunt to get any purchase, so I grabbed a scalpel and that worked a treat.
To get it out with a scalpel type blade by snipping the blade down and tilting it up like that. Yes. Pump mode 2. Socket. This one is fixed. That's both the rubber key Spectrum sorted. The next one in the pile are all ZX Spectrum Plus versions. Never worked on a Plus before. That will be interesting. Well, for me. Hopefully for you too. Well, it's a pretty safe bet. I mean, if you're still listening to me rambling all the way to the end of this video, it's likely you might find a blah, 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 drone. Okay then. Bye.